We did a lot of analysis, a lot of data conversions. Let's say you have figured out a command that you want to run on one of the inputs. And now you want to run this input on multiple files. There are many different ways to do it. If you are familiar with shell scripting and Linux, you can write a for loop right there on the command line and use that to run it sequentially. I want to show you my preferred method using Python. Doing this via Python allows you for a lot more control over how your data gets processed. Plus, you can integrate this with the rest of your pipeline. So I'll learn this, and I have two scripts which I want to teach you. If you know basic Python, you'll be able to follow that quite easily. If you do not know Python, I'll explain the structure of it and how to run it. We'll also try to run it on your own machine. And then you'll be able to modify the script a bit to add your own command. So the first step is to figure out command for a single file. Let's say our problem is we have this data that we had worked with for the USDA NAPE data. We have this multiple GP2 files, and our task is given to us is that we have all these GP2 files. We want to convert them to COGs. Okay, maybe that's our task. So you can say, okay, I know how to convert this. I learned this in the class. We'll say output format COG, input file. We'll say this is my input file. Let's say output 1.1.gp2. And my output is same output 1_1.diff. Just use all the basic option. And then it worked. So we converted this GP2 file to COG. Now we say, I have to do this 10,000 times. I have 10,000 files. How do I run the same command again? But my input and output has to change. So I'll teach you, once you have a command that works on one file, how to run it against all the files. Let me just delete this diff file that we created. We're on your root folder in GDAL tools, we have a Python file that we have included in your data package. The Python file is called batch.py. I'm going to open it with the text editor that I have on my system. This is what the file looks like. It's a Python file. This is a Python file. Very simple. It says when you run it, it wants to run this command. So we first create a text line. It says, this is my command line that I want to run. Here, instead of COG, I had used diff. We can just use COG, whatever. Whatever command that we figured out. We just say, instead of giving a file as input and output, we just put this in the square curly brackets. So this says, this is my input, this is my output. This is the command. Whatever command you figured out for one file, you put it here. Then we say, let's just get a list of files. So we use this command os.lister. Give me all the files that end with JP2. We'll get the input name, we'll get the output name. And we'll first comment this out. So I'm going to just print this, that my input is and our output is this. Just to show you that this is, we're extracting the input and output file names from this. We'll save this and run this. Don't do anything yet. You get a chance to run this. Let's just run the script. So you can see we have this batch.py here. We can say Python batch.py. This just goes through all the files and says, this is my input, this is my output. You can say my input is this JP2 file, output is this file, diff. So I'm just iterating through the list of files, constructing the names and paths of my input and output in this loop. That's what it's doing. Once I have my input and output, I can say, use this command, os.system. This is a Python command that says, whatever is here, run this on the shell, on the terminal, on the operating system. And we say, this is your command that we have. Replace the input with whatever input for this particular iteration. Replace the output with whatever is in this iteration. Let's just run this. So I'm going to save this. Now I've uncommented this. And we just run this Python batch.py. You can see it's just running one after the other. It's running in a for loop, taking the input, running the command GDAL translate on the output. You can start this, go have a coffee, and then when I come back, I'll have all my files translated. You can do this in a single line if folks who are familiar with shell scripting. just write a simple shell script to do this. The idea is the same. You take all the files in a directory and say, this is my input. Whatever changes you want to make to the file name or path, you can then create an output of that. Yeah, and this will keep going. And in a few minutes, you'll have all the files converted. Now, this works for everything. OGR commands, GDAL commands, span sharpening, raster conversions, anything. So you just say, this is my input, this is my output, I can run it on that. If I want to change something, I have to come and change this on my Python code. So let's say instead of putting the output in the same directory, we want to put it in a different directory. We have to change the code and say my output will go to an output directory. So I'm going to create a new directory called output. And now when I run this, it'll say my input is coming from nape, the output is going to this output directory. Right? Just you have to change your code to construct a path for the input and output files. And when you run it, it's going to run this in the batch. Okay, I want all of you to try this out to see how to run this command. So to do this, you first come to the root folder. So on your root folder, GDAL root folder, make sure you have this batch.py. You don't have to change anything. You just have to come and type Python batch.py. And when you run this, it'll start running this in a loop. So start this and see how it creates these new files. As it's doing it, you can check your directory of the nape folder, and you'll see there'll be new TIFF files that are being created by converting the JP2 into the TIFF format. Okay, so try this out by just typing Python space batch.py from your data folder, and it should start process. On the terminal, when you want to cancel something halfway, this might take like 10 minutes to finish in the system. If you want to cancel this halfway, Control-C is the command. You just press Control-C on Windows, Command-C on Mac. It should be able to cancel this. Or you can, sometimes just close the terminal and it'll just stop. This also has an advantage that you can integrate it with the rest of your workflow. Let's say you are doing some more complex stuff in Pandas or extracting something from a database or calling an API. Once you have this, say I have this files now, let me run a GDAL command. And you can just execute that on a system. And then once you have the result, you can do something with it. Every time I need to now do some batch processing, I'll just find my script here and just replace the command here and run it on a directory full of files, and it works. The reason to do this with Python also is shell commands, GDAL, everything is sequential. It only runs on one core of your CPU. So even if you have a very powerful system, you can't leverage all your computing power. Python offers you another way where you can leverage something called multiprocessing. Instead of running this in sequence, you can say, run this one process per core. So I have 4 core machine or 16 core machine. I can process 16 data together. And that's another reason to use Python for doing your batch processing. So you can save some time and say, instead of doing this, I will use my batch processing. So using parallel computing. Let's see a better way to do this. So the same structure remains, but now we'll use all the computation resources that we have at our disposal. We're going to learn about the next template of the file, batch_parallel. So let's open this and see what this file looks like. A little more complex. Here we are using the Python multiprocessing library. Same structure. We say we have the command, and we have for each file, we'll get input name, output name, command. Instead of just running in a for loop, we are putting it inside a function. So this is a Python function, which takes a file name as an input, runs the command. And then we say we have all our files, the list of files. We create a pool of 4 processes. So 4 refers to the number of parallel processes that we want to run. You can have as many as you want. Typically, 1 per core of your CPU is ideal. So I have a 4-core CPU on my machine. So I'm doing 4 multiprocessing. So we'll run 4 processes at a time. And this command says, I have 4 machines, run this process on all these files. So it says for all this list of files, run this process in parallel. So this will run in parallel. What happens right now, it starts the 4th process. The first one finished faster. it's going to say, oh, my first core is free now. It'll start the second one while this other cores are busy. So it's going to manage the process for you as and when the process keeps finishing, it's going to launch them on the appropriate cores. And once it's done, you can do this. And I'm adding some start and end time if you want to compare how much time you saved versus sequential. So this one is a sequential one where you say for files, run this, or you use the thing, you will save some time. When you do this using Python, you will not get 4 times the performance benefit. If you have 4 machines, it's 4 cores, it's doing it in parallel, but there is an extra overhead for Python to manage all of that. Oh, this machine is finished, I'm going to track that and launch that. So there's overhead to manage all this communication. So maybe get 2 or 3x the time of performance. So if your sequential takes 10 minutes, this might save you 5 minutes and you can get it in half the time. But that's still significant when you're doing a lot of data processing. So if you have machines, why not just use the stuff that you're at your disposal? Let's try. I'm going to remove the second part. I don't want to do the sequential one. And I'm going to run this. First, let me run it and explain, and then you can try this out. So I'm going to do Python. And we're going to say batch. Let's go parallel. And starting, you can see it started the 4 commands. After a while, things can start jumbled up, right? You can see it. Everything is kind of doing haywire because it started. And as and when the process are finishing, Python is launching the processing in between. So you can see all of this are kind of running in parallel, the 4 processes. As the first finishes, it starts the 5th one, second finishes the 6th one, and so on. And it's going on, it's going to do this. I don't know if you can hear, my CPU fan just turned on because I'm using all my cores, so it has to cool it down. But so you're using all the computation resources that you have. You can also do this on the cloud. If you have a very large processing workload that you want to do, rent a very large machine on AWS or GCP. Say I'll rent a 64-core machine and I'll run the script and I'll get my data processed and then I can turn off the machine. So you can see I could do this in 43 seconds, which would be, in my case, like 2 to 3 times faster than I could do this in a sequential way. So try this out on your system. Go to the root of the folder and type Python space batch parallel.py.